Good afternoon, students. Today we will start the new unit, unit 3rd, that is fats and oils. In this unit we will see the different point like fatty acids, different reactions for the fatty acids, then hydrolysis, hydrogenations, saponification, rancidity of oil, drying oils, etc. And then analytical constants like acid value, saponification value, ester value, iodine value, acetyl value, Richard Missel value, significant and principal involved in their determination. Okay, now we will start in the today's video like general what is the general definitions of fats and oils, properties, how it looks, what are the role of that fats and oils in our body, etc. Now complete watching of this video, student can explain or student can able to tell different definitions of fats and oils or general properties. They can mention different general properties, etc. Now let's start the video. We will start by the definitions, different definitions. Okay, lipids. When fats, lipids, oils, it comes in your mind, then you will realize or you can remember the oils, oil, how it looks. It is liquid and viscous in nature, like that. Fats is like solid in state. They can't flow, means they have high viscosity. Okay, like that. Now lipids triesters of long chain of fatty acid with glycerol. What is the definition of this lipid? Lipid is triester. It is a triester of long chain fatty acids with glycerol in there. Then fats, triester of long chain of saturated fatty acids with glycerol. Example, wool fat. Fat means this is also triester of long chain fatty acids. But here which type of fatty acid is present in fat? Saturated fatty acids. Saturated fatty acids means, what is the difference between saturated and unsaturated? Saturated means they contain carbon-carbon single bond, whereas unsaturated means here it contains carbon-carbon double bond or more than that, means double bond, triple bond, etc. So here this is the definitions for the lipids and fats. Then what is oil? Oil is a triester of long chain of unsaturated fatty acids with glycerol. Means it is a triester, but it is a triester of what? Triesters of long chain of unsaturated fatty acid with glycerol. Okay, now fat and oil are able to saponify, but steroid aren't. Means here fats, this both fat and oil, they can form the soap. Saponification means it forms the soap, where means when fats and oils are reacting with KOH, NOH, sodium hydroxide or potassium hydroxide, then it forms the salt of that acids or oils, and its salt, and after reacting with this base NOH and KOH, it will get form the soap. That is, soap formation means is nothing but the saponifications. Means this fat and oil they can form. Whereas steroid also like this long chain of unsaturated or saturated fatty acids, but it is not saponifiable. Okay, so this is the some properties of this fat and oil are easily saponified, whereas steroid aren't. You just keep in mind that means in MCQs you will ask the question like following are the saponifiable. Then option might be fat, oil, then the steroid, and something else. Okay. Then what is fatty acids? Fatty acids are long chain of carboxylic acid are known as a fatty acids. It contains long chain of carboxylic acids. Then saturated fatty acids contain carbon-carbon single bond inside chain of carboxylic acid. Example, stearic acid. As name itself indicate the meaning of the fatty acid. Saturated means it contains the carbon-carbon single bond. Then unsaturated fatty acid. Unsaturated fatty acid contain one or more carbon-carbon double bond in the side chain of carboxylic acid. Example, oleic acid 18s1. Okay. Unsaturated means here carbon-carbon double bond. Then what is the next definition? Saponification. Fats or oils are able to form salt or soap with alkali NaOH or KOH. Saponification means any fat or oils to form salt, soap or soap with whom? With alkali like NaOH and KOH. Then what is rancidification? Rancidification is an oxidative or hydrolytic product produces obnoxious odor and flavor. Rancidification means your oil might be stored for a longer period of time in open space under the sun or like that, then it get degraded. So after degradation it forms obnoxious odor and flavor. It forms means rancidification occurs in that oils, so it becomes very dirty smell and as well as the taste. Then what is hydrolysis? Hydrolysis, breaking of triesters with water to form fatty acids and glycerol. Hydrolysis in simply what is the definition? Addition of water. So here what happens? Breaking of triesters. That triester is breaking with water and they get form the fatty acids with the glycerol. And then what is hydrogenation? Addition of hydrogen to oil in presence of reducing agent to form fats. Reduction is nothing but the addition of hydrogen in the presence of catalyst. So here hydrogenation is means is simply here addition of hydrogen to oil in presence of reducing agent, means different metals like copper, nickel and whatever etc. This type of metals or catalyst, they act as a reducing agent. Hydrogenation, this hydrolysis, this rancidification, saponification, hydrogenation, this type of these reactions we will see later in briefly. Now what is wax? Ester of fatty acid with high molecular weight, that is monohydric alcohol, is wax. Okay, means it contains the monohydric alcohol in their structure. Then what are the functions of lipids or fats in our body? Storage form of energy. Okay, storage form of energy means it is a source of energy for human body. Important dietary component because of their high energy value and also because of the fat soluble vitamins and the essential fatty acids contained in the fat or natural foods. Okay, means what is the role here? In natural dietary food, they contain the essential fatty acid. uh, also they have the like fat, different fat soluble vitamins, they are remaining in their fat in our body. So fat soluble vitamins, they are soluble only in fat present in our body. So this is the one function of this lipids and fats in our body. Then structural component of biomembrane in our body. The body is our body, here happens number of biochemical reactions and different cells and different cells, different tissues and different components are present in our body. So mostly they are composed from this fatty acids and oils. So this is the one importance of this fat and acids. Then serve as a thermal insulator in the subcutaneous tissue and around certain organs. They act as a thermal insulator around any organ tissues. Okay, Then non-polar lipid act as a electrical insulator, allowing rapid propagation of depolarization waves along myelinated nerves. In the nerves is which passes the messages. If a motor nerve, sensory nerves, they are present in our body. They have very important function in our body. So it requires what fats and oils in the structure for formation of nerves and for proper functioning of their nerves and cells. Okay, now provide shape and contour to the body. Because of this we person get the certain shape, thin, thick and all. Act as a metabolic regulator. They are involved in metabolism. Combination of lipids and protein. Lipoprotein are important cellular constituents occurring both in the cell membrane and in the mitochondria, and the serving also as a means of transporting lipids in the bloods. Okay, means in the our cellular level, it is cellular level, organ level, tissue level and any level. Means in the body it requires the fats and oils for proper functioning of the body. Then biological importance of fatty acid. Fatty acids are the building blocks of dietary fat. The human body stores such fat in the form of triglycerides. Means this fats are fatty acids are building blocks for the dietary fat. Means dietary fat they get from the our body, and the body they have the important role. Fatty acid also required for the formation of membrane lipids such as phospholipid and glycolipids. This different membranes in our cell they forms with the help of these fatty acids. They are required for the esterification of cholesterol to form cholesterol ester. They act as a fuel molecule and are oxidized to produce energy. After biochemical reactions of this fatty acid, they give us energy to the human body. Then here they have mentioned different examples like saturated fatty acid. Which are the saturated fatty acid? What is the structural formula, molecular formula, and what are the examples under that saturated fatty acid? They have mentioned first butyric acid. Butyric acid which contain which contain 4 carbon atoms in their structure like CH3, CH2 twice, and then carboxylic acidic functional group. Example of this butyric acid is butter. We are using in general life in your cooking and all. This butter is nothing but butyric acid. Butyric acid means it contains 4 carbon atom in their structure. What is the next example? Caproic acid. Caproic acid it contains 6 number of carbon atom in their structure. Example of this caproic acid is butter, palm oil, coconut oil. Then what is the caprylic acid? Next is the caprylic acid. Caprylic acid it contain how much carbon atom? It contain 8 carbon atom in their structure. Like palm oil and coconut oil is another example. Then capric acid. Capric acid which contain 10 number of carbon atom in their structure. Palm oil, coconut oil is the example of this capric acid. Then lauric acid. Lauric acid which contain 12 carbon atom in their structure. Like plants of lauraceae, coconut oil and palm oil is the example of this lauric acid. Then marastic acid. Marastic acid which contain 14 number of carbon atom in their structure. Example of this is seed fats of maize, butter, coconut oil. Then what is the next? Palmitic acid. Palmitic acid which contains 16 carbon number of atom in their structure. Like example palm oil, peanut oil, plant fats, etc. Then what is the next? Stearic acid. Stearic acid which contain 18 carbon atom in their structure, which is from plant and animal fats. These are the example for the saturated fatty acids. Then unsaturated fatty acid. You shall keep in mind that this type of example they can ask in your MCQs. Okay, so how much carbon atom in their butyric acid, in myristic acid, or they might be asking like what is the example of caproic acid, what is the example of lauric acid, what is the example of stearic acid. Okay, or from which source they can obtain, this type of questions they can ask. So you just concentrate on that things. Then unsaturated fatty acid. Unsaturated fatty acids, they contains carbon carbon double bond or either carbon carbon triple bond in their structure. So look it here. First is palmitoleic acid. Palmitoleic acids, here example is sardine oil. How much carbon atom they contain? They contain 5 1 8 9 10 and 16. Okay, 16 carbon atom in their structure. Example of this palmitoleic acid, example is sardine oil. You should go through this unsaturated fatty acid. Will get from Google search, or you can get from this different book source. So you just go through that what are the unsaturated fatty acid, what are the example, different example, how much carbon atoms they involved in their structure, like that. Then essential fatty acid. Essential polyunsaturated fatty acids such as linoleic and linolenic acids are essential for normal life functions, because it is required for proper normal functions of your body. Okay, they are therefore characterized as essential fatty acid. So they are characterized as essential fatty acid. Essential because it requires for your body. Then arachidonic acid is considered as a semi-essential fatty acid since it can be synthesized from linoleic acid. It is this arachidonic acid is called as semi-essential. Why semi-essential? Because if we get linoleic acid in our body, from that they can be synthesized in your body. So it is semi-essential fatty acid. Example of this arachidonic acid. Then what are the physical properties? Colorless, odorless, tasteless. How it looks? Fats and oils, they are colorless, odorless and tasteless. They don't have any taste like sweet, sour and some like that. Okay, then insoluble in water, as it is lipophilic in nature, lipid loving, so it is insoluble in water. They can't solubilize in your water. They can easily differentiated from that water. Then specific gravity is less than 1. Consequently, all fats float in water. Specific gravity is less than 1. Means for example, like density is less, so it is easily float on water. Then oils are liquid at 20 degrees Celsius. They contain higher proportion of unsaturated fatty acids. Oils are they are liquid at 20 degrees Celsius. Okay. Then fat are solid at room temperature and contain saturated long chain fatty acids. Whereas fat are how they are saturated long chain fatty acid, and oil are unsaturated fatty acid. Oil are unsaturated and fats are saturated fatty acid. You keep in mind. Okay. Then triglycerides are the storage form of energy in adipose tissue. Okay, triglycerides are it is a source for the energy in your adipose tissue. Here some facts of that fats and all. Fats protect internal organ from shock, injury, insulate the body, and promote healthy skin. Fats provides 9 calories per gram. Okay. Then what is definition? Fat, a nutrient that is essential for body energy, insulation, and protector. Okay, this fat can act as a energy source, nutrition, and it is insulation protector for the body. This is some example like butter. Butter is example of fats. Then all vegetable, criscomins is like dalda. Example of dalda is type of fats. These are the some examples, branded example they have shown. Okay, oils, fats we can get from food, like from plants oil, or from fish. From that we can get the different fats. This is structure how it is look. Fats means when glycerol is reacting with 3 molecular of fatty acids, they form the fat, that is triglyceride. Means here H2 is removing out HH, and is means this alcohol and acidic group reacting compile together to form the ester functional group. Okay, this is all about today's lecture. Next lecture we will see the reactions for the fats and oils, different reactions like saponification, hydrolysis, like that.